This is the exam to review. It doesn't always transfer perfectly, as you can see. 250 from the control tower as shown in this figure. If the control is 15 meters tall, we got that. So we're trying to find H. And D is 500, is that correct?
Yeah.
Okay. Okay, I think we got it. So what we're trying to find is H. Does anybody have any ideas what we can do?
Um, Got to do the Pythagorean theorem to find that one portion on the right side, right?
Sure, we can do the Pythagorean theorem. I'm not actually sure that that's the easiest way. Now, this is a calculator problem. Well, is this a calculator? This actually is not a calculator problem. We can do this one without a calculator. And we can do it a lot easier than using the
Inverse
Pythagorean. Excuse me?
Would you use like inverse cosine?
Yeah. So what I'm going to say, exactly, I'm going to say that the cosine of theta, which is equal to the adjacent over the hypotenuse, is equal to 250 over 500, which is equal to 1/2, right? That's how I knew, as soon as I looked at it, I could tell I don't need a calculator for this. Because if I want to know what theta is, we could either do the inverse cosine, but it's not even that necessary to do it that way because we can say we know what theta is. We don't really know what inverse cosine is that well without a calculator, but we know there's an angle that makes cosine 1/2, right?
Right.
So what is that angle?
60.
60 degrees. Okay, perfect. So we know that we already found theta. Theta is equal to 60 degrees. And I should be able now to find what H is. Well, maybe not H, but I should be able to find this, right? Because that's what would we call that?
That would be our H plus 15, right?
We're going to get H. Well, not H plus 15. H equals whatever this is. We'll call this rocket height.
Oh,
Okay.
gotcha. Okay.
That's rocket height plus 15 would equal H. So let's write that. Write down what you know. That way later you can go back and make sure you get it correct. Good. So how can I find the rocket height?
With the sine of
Perfect.
60.
Sine of 60. Now we know theta. So we can say the sine of 60 degrees is equal to the opposite over the hypotenuse, which is equal to r sub h over 500. Do we know what sine of 60 degrees is?
3 square roots of 2. It was 3 square roots over 2.
Square root of 3 over 2. And then that equals r sub h plus 500. This is exactly what I expect on an exam. Okay? Like, don't do anything more than I'm doing. And I can say now that r sub h is going to equal 500 times the square root of 3 over 2, which is really equal to 250 times the square root of 3. We know that h is equal to, well, we said it was r sub h plus 15, so it's 250 times the square root of 3 plus 15. And that's in meters. Please put your units down after you're done. Is there anything that I did here that confused anybody? You didn't know where to start? What is it that would make this problem hard, or at least hard to decide what to do?
I guess the first thing would be to find the angle degree, correct?
The first
So it'd be
thing,
like
would be to find the angle. Why is that the first thing?
Because then you could fill out the rest of the sides with the angle.
Right. Now you could use Pythagorean theorem because that was the first suggestion, right? But
Right.
I don't really want to square 250 plus 500 squared, add them together, and then find the square root. Now it may be easy, but from the looks of it, it wouldn't have been,
Right.
right? So I want to use my trigonometry whenever I can to make things easier. That's why that's what the first thing I do is find the angle.
Okay.
Okay? Because I want to explain why I do things the way I do in the order I do them. And why I didn't use a Pythagorean theorem. So that you understand. Is there any other thing that I did that you would have done different, that you want to know why I did it the way I did it?